So this is the last video before we actually go into the tutorials with some of the basic knowledge you need to write your own controllers with Webots and Python. And we are going to discuss now about something very important in Webots, which is this functionality robot.type time step parentheses n. Remember, this dot here means that we are accessing functionality from this library. So here we have the robot library and we are accessing its time step functionality. So in the real world, things happen continuously. If I throw like a stone in a lake, the stone is going to move continuously in an analog way, and then it's going to bounce for the waves, and it's going to generate waves, and everything is going to be continuous. In a simulator, on the other hand, everything happens on a discrete way. So actions are executed every time the simulator is updated. So, in the real world, I throw the stone and the stone continuously moves. In a simulator, the stone doesn't continuously move. It moves like every time step, which obviously the time step is going to be very small. And we are going to have the illusion that it is continuously moving, but it's not. And yeah, nothing happens between updates. So if the stone movement updates every second, on that second, nothing happens. And if you play video games, this is not different to the way video games are updated, which is usually every 30 or 60 frames per second. Um, if your computer is not very strong, or if you play like a very new game, you will see that sometimes the frames are like really slow, like something like 10 or something like that. And you then will see like the images like freezes continuously as it's moving, because that's where the computer is making calculations to show you the next frame. So in a simulation, it's exactly the same. I guess the main difference is that in a video game, when it gets slow, it's just annoying. But in a simulation, because we actually want to simulate the real world as accurate as possible, this is quite important. So Webots uses two different time steps. One of them is the simulation step, which is specified on the Sentry Wall Info basic time step. This is something that we modified at the end of the tutorial when we were messing with the things, when we changed 32 to 12, 32 to 16. So there they were saying that, the whole simulation, the whole world of physics and everything is going to be updated every 16 milliseconds. But then there is the control step, which is a specific argument for every robot. So with the previous step, we are controlling the whole simulation of the physics for everything. Meanwhile, with the control step, we are actually controlling the simulation time step of one specific robot. And these two values can be different. So the simulation step, for example, can be 16, and the control step can be 32, for example. Like it depends on how accurate we want our robot to be. And here at the end, I say that in the real world, the simulation step is a continuous value. So if we have a robot that is throwing stones, the way the stone is, floating around the air and moving is a continuous value. But robots are actually, they move on a discrete value because they are controlled by computers. So in the real world, if you have a robot arm doing something in particular, even though it might seem that it's actually continuously moving, it's not. It's a computer sending commands like at a very high frequency. So yeah, as I was saying, the robots has two different time steps. One of them is the simulation step, and the other one is the control step. So the simulation step is the value specified in the scene tree in world info basic time step in milliseconds, and it indicates the duration of one step of the simulation. For example, the time interval between two computations of a position, speed, collision, etc. of every simulated object. I hope you get the idea. For every simulated object, time step is going to, like the simulation step, is going to tell us like how much time is going to take between them. The control step is the duration of an iteration of the control loop of a robot, and we use the function robot.timestep n to advance the controller time step the specific duration. So here I'm saying n, but n is actually going to be a number like 16. So for example, if I do something like robot.timestep 16, we are going to advance the simulation of the robot by 16 milliseconds. And then it also synchronizes sensors and actuators data with the simulator according to the controller time. So, you know, the sensors and the actuators, the sensors are receiving data from the world and the actuators are manipulating the world. So we need to synchronize them with the real world. So we are going to have constantly a conversation between the simulation step and the control step, you know, because the robot is going to move an object, and this movement of the joints of the robot is going to happen based on the control step. But then the way the object actually moves is going to depend on the simulation step. Finally, the most interesting thing is that every robot controller needs to call the robot.timestep function at regular intervals. If a controller does not call it, then the sensors and actuators won't be updated and the simulator will block. So basically, if we want our robot to move around and to, you know, receive things from the environment, we need to call this function. Hopefully, with the next example, this is going to be clearer. So this is one of the most basic snippets of Webots code that you are going to find around. So let's go line by line. So the first line says from controller import robot. We discussed the imports previously. So here what we are saying is from the module controller, which is quite big, import the robot functionality. So from now on, we will have access to the robot functionality. The next thing we are doing is we are doing like robot equals robot parentheses. So here what we are doing is that we are creating a variable, and the name of this variable is going to be robot. And we are going to assign to this variable a robot as created by the controller module. So if we type robot parentheses like this creates a new robot, and then this robot is going to be assigned to this robot variable. And finally, the most interesting thing here is that we have while robot.step32 is different at -1, print hello world. So remember that this is a while loop, and this is going to be executed while this condition is true. So robot.step by default is going to return a 0. It's only going to return a -1 when the execution stops on when there is a problem. So robot.step32 is going to return a 0. 0 is different from -1. So this like admiration equals means different. So 0 is different from -1. And therefore it's going to come to the body of the while loop, and it's going to print hello world. So remember what we said in the previous slide. When we do robot.step32, we are advancing the simulation 32 milliseconds, sorry. So we come here, we do robot.step32, we advance the simulation 32 milliseconds, and then we execute this, and then we go back here and we execute again robot.32, which means advancing the simulation 32 milliseconds, and we print hello world here. So here is like really simple, but here you can imagine that, you know, we will do things like acquire images from sensors and actuate joints or things like that. And those, you know, images that we will acquire and those sensors that we will actuate, they will be updated every 32 milliseconds. So if I think this is something that you will learn by actually doing the examples that are going to follow. If you have any questions, you can ask me. But if you're a bit confused at the moment, I think the best thing is to actually try the examples, and I think everything is going to become clearer. But yeah, if you have any questions, feel free to ask me.